All right, so let's look at this problem in our notes, 417. It is moment about a point. So here we've got two forces. They give us these two forces already in IJK form. Determine the total moment by those forces about point O. So it is moment about a point. Moment about point O is R cross F, where this R goes from the point to the force, or from the point to the line of action of the force. Now, I could do R cross F of that one, and then R cross F of that one, and then add them at the end. But actually, since the R is the same, for both forces, and technically, because two forces that are acting at the same point, we could combine them anyway. But anyway, since the R is the same, I'm going to go ahead and combine them before I get started. So the F total, because they are these two forces acting at the same point, just go ahead and add them together. So that one plus that one, add the i's, add the j's, add the k's. Let's see what we have. Negative 100 in the I, plus 130 in the j, plus 175 in the k. That's the total force acting at A. So now I can do R cross F. So I like to, so first of all, you've got to notice that it's moment about a point, and moment about a point is R cross F, not F cross R, right? R cross F, where R is the position vector from the point to the force. So what is R? So I like to kind of take this R cross F and kind of break it down into smaller bite-sized pieces. Let's just look at the R. What is R? What is R that goes from the point to the force? From point O out to the force A. What is its I, J, K? How far does it go in the X direction? 4 in the I. How far does it go in the J? 5 in the J. And then it goes up 3 in the K. Now, I'm not going to divide that by its magnitude. This is not an R over R. It's just an R. Leave it as an R. It does have units, and it needs units. All right, so there. I've got the R right there. And then I just had the F right there. So now I'm ready to do my cross product. You can do yours differently, however you like to do the cross product. I do it of this 3x3 determinant, where the top row is my I, J, K. The middle row is the next one, the R. Got to get these in the right order. The middle row is the R. The R is 4, 5, 3. And then the force, negative 100, positive 130, positive 175. All right. So you'll see how I like to do my cross products. But first I take this I and do that minus that. Right. I take this. My I component is going to be this. 5 times 175 minus 3 times 130. All right. And then my J component is going to be negative J, and that's just how determinants work. Right. That negative is there so that I can do that minus that. All right. 4 times 175 minus 3 times negative 100. So be careful with these positives and negatives. You can see why it's easy to make a mistake. And then I'll do a different color. We'll do the K component, and this is the positive. And so K would be this minus this, right? 4 times 130 minus 5 times negative 100. And so I would get 485 in the I. And then the math would give me negative 1,000 in the J. And then finally, positive 1070 in the K. And so that is my moment about O. Don't try to combine them together. The moment is a vector. It might have I, J, it might have K. And so these are pound feet. So that's the total moment about O. What it really is it's saying it kind of has this twisting around the K axis. It kind of has this twisting around the J axis. It kind of has this twisting around the I axis at point O, caused by those forces cause at point O. So there's my moment about point O.